In Lesson 2-2, we're looking at the equation for a line in point-slope form. Now, again, we're going to look at special information that's visible in point-slope form. The reason it's called point-slope form is just that. Here we see our m, again, that's the slope part, and the point comes from the fact that we have a y and an x, or if you will, the x and the y that make up a point. Now, you might notice these little subscripts here that have a little 1, kind of like think of a submarine. The subscript is a way to note these are part of the same point. So if I have x1, y1, they're on, say, team 1, the first point. You could have something like an x2, y2, or an x3, y3. Those would indicate they're on the same point together. And again, that's why we call it point slope, because we have a point, an xy point, and a slope that are listed in our form of the equation. It may be also helpful to remember that slope is called rise over run. So if we're ever wanting to graph a slope, fractions are not too daunting. For example, if we wanted to take the equation y minus 2 equals 4 times x minus 7, you might think it doesn't look like the slope-intercept form that you might be used to. This tends to be what everybody likes to use, but it's more confusing to graph. You may find this actually is easier than it looks. Our slope here is this m, because note that it's in the same position here as the m is in the equation. My slope is 4, or 4 over 1. Remember, if you don't have a run value listed like a fraction, you will just add the 1. The point is the x and the y values listed. So over here with my x, I have minus 7. Minus is already a part of the equation, so the 7 is my x value. At y minus 2 indicates just this 2 part is my y value. So instead of starting at the y-intercept like we did on the last section, we're going to actually start at the point 7, 2. I will plot that dot first, and from this dot I will now slope a rise of 4 and a run of 1. I could do it again, or I could go the other way. A negative 4 divided by a negative 1 would also make a positive 4, and this would be my line. Now, if we wanted to keep going and find the y-intercept, we could keep our pattern of down 4 over 1, down 4 over 1. You'd note that we'd run out of room. We could extend our graph and eventually hit the y-axis somewhere down below negative 15 or negative 20. But another thing you can do is actually convert this point slope form into an equation that looks like slope-intercept. We would do that by simply multiplying our 4 into both of those x values. So I'd have 4x minus 28, and on this left side I still have y minus 2. We know slope-intercept, the favorite original one we've always used, has just y by itself. So if I add the 2 to both sides, I'll be left with 4x minus 26. And sure enough, that's your slope-intercept. If I kept going down here, it would cross the y-axis at negative 26. It will be very useful to convert point slope form into slope-intercept. Real quickly, we'll try this last example here. I would note that my slope is negative 3/4. So of course, if you recall, the negative slope goes down to the right. It will look like this. And my point comes from the x value in here. Now you see a positive one, but you want to write the opposite, because it used to be a minus sign in the formula, and a negative 1 would make minus a negative become positive. So I like to just think of it as the opposite of what you see here. If it's x plus 1, negative 1 is your x value of the point. Because I see y minus 6, 6 is the y value. So I will plot negative 1, 6, and I will slope rise negative 3 and run 4. Rise negative 3, run 4. And there you'd have your line. Now notice it is possible to rise positive 3 and go left 4. As long as one of them is negative direction, you will have the correct line. One thing that can happen is you're trying to work with point slope and someone wants you to create the equation. So now I'm just given some information here. I've got lots of info or points here, and I want to turn it into an equation. It didn't ask us to graph, but we can if we'd like to. So I want an equation that passes through -4, 1, and 2, 3. I would like to show you how if you're struggling with math and formulas, you can just plot -4, 1 and 2, 3 and connect those points very carefully with a straight edge, and it will help you visualize the line. But let's come back to that in a little bit. If I want to use a point here, I could use either of these points for point slope. The trick is I don't have the slope. So we're going to go back to an old formula you may have seen before. Subtract your y values for the rise and subtract your x values in the same order for the run. My y values are the second ones listed. So I would have, if I call this my second point, I'd have 3 take away 1 over my x values of 2 take away -4. Being very careful with your subtraction, I get 2 over 6, which reduces to 1 over 3. This is my slope. And while I wasn't given the slope, I can now count my slope as 1/3 and use either of these points. Now let's check. If I went up 1, right 3, there's where my line hits. Up 1, right 3. You can note that I did have 1/3 as my slope, or you could have seen 2 over 6, up 2 over 6. That's our reduced form. For the equation then, now that I have the slope, I can use either of these points. So 1-point slope form could be y minus 1, because of this 1 right here in the first point, equals my slope times x plus 4. You might wonder where the plus 4 came from. That's because we had -4 as an x value, so we think of the opposite. Now, if someone gives you point slope form, but they actually wanted it in slope intercept, remember, we can multiply our slope through with our distribution property. That gives us y minus 1 equals 1/3 x plus 4/3, and then I would add 1 to both sides, and that would give me y equals 1/3 x plus 7/3. Not super pretty, but 7/3 is a little over 2. And check out over here that my y-intercept is indeed a little bit over 2, or exactly 2 1/3. This process of converting point slope to slope intercept can be super helpful. But remember, if you're really stuck, you can always plot your 2 points to find slope, and in a worst case scenario, at least estimate where it's crossing the y-axis.